Click the link in the description to download your own copy of this video's problem. Email drbetts@protonmail.com if you would like a copy of every problem in this series. Hey guys, Russ here, back with another fantastic organic chemistry video, and today we're going to talk about hybridization. Fundamental problem in organic chemistry, pretty much guaranteed. First exam is going to be on there, pretty much guaranteed. So you may as well learn it. You may as well learn how to do it right. It's really, really simple. All right, let's do this question. What is the hybridization state of each of the atoms with an arrow? Okay, very good. So here we have this box, this arrow, pointing at this atom right here. It's an alcohol, but that's not what it's asking us. Common mistake students will make on this kind of question. Common mistake students will make on this kind of question is they'll give me the class of compounds. Don't do that. I want the hybridization. So it can either be sp, sp2, or sp3. Well, here's an oxygen that doesn't resonate, and it's not involved in a double bond or a triple bond. So it has to be sp3. sp3. That means the lone pairs that are on this oxygen are in sp3 orbitals. It's going to have a tetrahedral electronic geometry, bent molecular geometry, of course. All right, next, this one, pointing at that carbon right there. That carbon is involved in a double bond. So it's got a pi bond. It's got one pi bond. So it must be sp2. Carbons involved in double bonds that have one pi bond are sp2. Moving right along. This nitrogen. This nitrogen is not involved in resonance. It is not involved in a double bond or a triple bond. So it must be sp3. No pi bond. That lone pair is inside of an sp3 orbital. The electronic geometry will be tetrahedral. The molecular geometry will be pyramidal. It'll be pyramidal or pyramidal. This one, pointing at that nitrogen. That nitrogen does have a triple bond. So it's got a couple of pi bonds. If it has two pi bonds, it must be sp. Two pi bonds, sp, all day long. The lone pair is in an sp orbital. It is linear. All right, moving along. This one, that oxygen is involved in a double bond. That means it has one pi bond for sure. So it is sp2. The lone pairs in this particular atom are in sp2 hybridized orbitals. And last but certainly not least, this one here, this oxygen that's involved with an ether. Again, there's no pi bonding. There's no resonance. There's nothing like that. So it must be sp3. Bent molecular shape, molecular geometry, tetrahedral electronic geometry. All right? So there you go. So that's how you'd solve this type of problem in hybridization. Now, I hope you liked this video, guys. If you did, slap that like button. Leave me a comment below. Let me know if this was helpful, if it was not helpful. What other kinds of questions should I be working on for you guys to help you be successful in organic chemistry? And you want to know what? If you have time, just slap that subscribe button as well. It really helps me out as a creator when you subscribe to my content. It lets YouTube know that my content is beneficial for the user. And last but certainly not least, I want to wish you all good luck and good chemistry. We'll see you soon.